So now that you know how the tool works inside of Unreal, and I hope that at this point you've been able to make some modifications of your own and play with the tool a bit, let's go ahead and have a look at how it works. Now in this workshop, it will take a bit too much time for me to go through a step-by-step recreation of these tools. So instead, I'm going to walk you through how the tool works, how its different functions work, and how it's integrated with the rest of the pipeline. So bear with me while we do that, and I hope you can use the example files that I've provided to have a look at how this works for yourself. You can basically just go through these nodes here inside the example file and have a look for yourself. Now what I'm going to do is I'm actually going to go to my tool here in Unreal. Just bring that back. And I'm going to make sure that this node is the only node that's currently loaded in the Houdini engine. Because what I would like to do is take this asset and how it is currently rendered and loaded inside of the Houdini engine and bring that into a separate Houdini scene. So I have all my meshes as well as this selection spline provided to the tool directly. Let's go ahead and do this, and I'll show you what that means. I'm going to shut down the Houdini engine. This means that it's going to purge whatever was already rendered out and stored in memory. I'm going to restart it. Okay, so now that we've rebooted the Houdini engine, we need to go ahead and rebuild this tool. If we do that, then this tool is going to be loaded into the Houdini engine's memory. And that means that when we open up a Houdini session from our Houdini engine menu up here, it's going to be the only tool that's currently visible within our interface. It's a little bit cleaner and it saves some of our memory, so that's why we do this. Also, before I go ahead and pull this into Houdini using OpenScene Houdini, let's go ahead and also add this spline here to the tool. Now this is one other function that I've not yet shown. If we go to the tool, we go to the World Outliner input here, we can add selection splines as well. And at the moment, if such a spline is set to inclusion mode, meaning under its settings, we've got it set to inclusion, then the tool will pick up on that and it will use it to modify our alpha for our stamp. Basically, the alpha that transitions it from the stamp to the terrain. Let's go ahead and go to our World Outliner input on our stamp tool, start selection. And what I would like to do is find our curve here, find one of the nodes on the curve, and click on it with Control. If you do that, and you also still have your building selected, you can then go and say use current selection, and the tool will now recognize this as an updated selection. If we don't see it update, just save. There we go. So now you'll notice that the bounding shape of the tool has been changed to match this selection spline. If we grab this and we move it inside of the town, you can even make the stamp only write out a part of the town. So this section here won't actually be terraformed. This will still be the original landscape, while this part here, of course, is terraformed. So we have a bit more control over the shape of our stamp in case we need that, right? Okay, so with this now loaded into the Houdini engine, let's go over to the Houdini engine tab up here and click on Open Scene in Houdini. And let's go have a look what this is doing inside Houdini itself. Let's bring this over. And then here we have our asset. So I'm just going to make my background a bit darker. And let's open up the asset itself. Now if we look over here, you'll notice that there's a lot of other objects being provided. These are basically all these little buildings that are being plugged in. And we also have our spline in here somewhere. Let's have a look. Should be this guy. Yes. So this is our blueprint spline. And the blueprint spline itself comes with a bunch of groups. This is how I bring the information from the blueprint into Houdini. And there's a function within the tool that translates that to attributes. So if we go back to the actual asset here, the mesh stamps asset, and we make sure only that is currently being rendered. And here we are. This is what the tool actually looks like in Unreal. If we jump inside, then here we have all the functions of the extract mesh stamps tool. Now we're going to go through the different steps on how this works, as well as how some of the nodes of the toolkit work, such as the load multi-caches node over here, which is grabbing our landscape data, for instance, as well as the road data that belongs with the landscape. And over here I have an example for the weighted height transfer node, which allows us to take, in this case, two different stamps and overlap them. We'll get to that. Let's start at the top. So the first thing we have to do is deal with our input. So since I've taken my scene from Unreal and I've used open scene in Houdini, this node now actually has access to all the information that was provided to the tool. And the first thing I'm going to do is filter out my selection splines. Now my selection splines come with these groups. These come from the blueprint spline, they're exported as tags, and this allows me to import them within Houdini as groups. You might also notice that some of these groups have special characters in them. That's because anything but the underscores has to be encoded as alphanumeric characters if you actually want to carry them over as a tag. For example, in this case, XX point will create a point, whereas other things like XX CMA is basically encoded as comma. If we actually go to the blueprint spline asset inside of Unreal and we look at that, then inside this node there's a function called encode, which, if we look inside that one, basically finds characters within our strings and encodes them as these types of lines with characters. This will allow me to later on decode it again. If you want to add your own special characters to this, you'll just have to add more functions to the blueprint, and then also go into Houdini and decode it here. Now the decoding process actually happens here on the left. So what I do first is I take this split node and I find one of these groups, in this case the selection method, and I filter out our blueprint spline. Then we go to the left, and in this case I'm looking for the selection method inclusion group. Basically, if we have set our selection spline to inclusion mode, like this one has, then it will come out as a tag. If we look under advanced and tags, over here as selection method inclusion. So that's going to be filtered out right there. If we have any exclusion splines or any other selection splines accidentally plugged into the tool, they will not be recognized. Of course, the tool doesn't tell the user that. If you want to do that, you'll have to build some kind of visual or feedback system into your asset. Next, we're going to feed it to the Massive Worlds process BP splines input asset. Now this is a open asset. You can find it under the E-Houdini Academy toolkit, Massive Worlds, open assets, and then it's down here as E-Houdini Academy process BP splines input. This node internally basically decodes that group and converts the attributes back into their respective characters. So it reconstructs your data. As a result, it outputs it now as attributes, so we can actually access that later. In this case, they are primitive attributes, so we can see it's a selection BP spline. There's also the road spline as well. It's a curve type, it's not a linear type. We are using the inclusion mode over here. and it has a selection proximity of 15 meters. Note that this is important because I'm actually using that as an attribute down here in the system. Let me just pull this up over here. So this is actually used to determine the fading distance of the stamp if we're using the inclusion spline. Let's get to that when we get to that. First, let's have a look at the footprint generation. So over here, I have all these buildings, and in this case, I have basically colored them by their Unreal actor path, meaning that each one of these buildings, even if they are constructed out of multiple individual meshes, can be identified using an existing attribute that's already provided by the Houdini engine. So I think that's this attribute right here. Now, with that, we can actually filter per building in this loop. So if I click on one of these loops, let's single one of them out, like the church here. Then what this node basically does is it takes our mesh. We're going to flatten it using a simple lowest of bounding box expression. All this does is it basically compresses the entire building down, all of its points, into a single flat plane at the bottom of the mesh. That's simple enough. Then I'm going to grab a bounding box of that shape, and I'm also going to expand that bounding box just a bit. Over here I have a parameter that's hooked up to the interface for the footprint expansion. And what that does is it basically makes this bounding box just a bit bigger in both its X and Z direction. Another thing I've turned on here is orient bounding box, which means that it tries to find the longest edge along the input mesh. Because I've already flattened the mesh, it shouldn't try to create some kind of other orientation. It's only going to rotate it on the top-down axes, the y-axis. I can then take that and only keep the top-facing primitive. Then this node here grabs the transform variable that the bounding node outputs, because I've told it to output transform attributes as an xform matrix attribute. If we look at it, we look at the detail attributes, you'll actually find it right here. This describes the transformation of the bounding box from the center of the map to this location. So if we go ahead and undo that transformation using a transform by axes node, and then we go and zoom in on that, it will be placed at the exact center of the grid, and it's going to be oriented in its cardinal directions as well. Now I'm just going to use the divide node with a 0.5 meter precision and breaker it. I'm not going to do anything else. As a result, we're going to add some detail to this plane. After that, I need to recopy back my xform attribute because this kind of got destroyed in the process. And then let's redo our transform, but in the opposite direction. So before this guy inverted the transform, this guy is going to revert that again. So we're basically going to restore it back to its previous position where our church is located. Then over here, I'm just using an XYZ dist expression. This grabs the closest point for every point on our grid, right? And looks for the nearest point in that church mesh. So since this is completely flattened, it's basically going to delete all of the points that are too far away from this shape based on this distance. That's also the reason that I've expanded the bounding box out, and I've expanded it twice. Because if I go ahead and grab my parameter panel over here and I go to the stamp controls, I can also go and expand this out. And notice how that makes the building stamp much more bloated, right? It makes it bigger. We're going to keep that to 0.75 for now. But you can use this to make the stamps just a bit wider, so its terraforming starts a bit further away. You can increase this to a larger size, and that will affect the terraforming, because terraforming will generally not start until the edge of this footprint. Alright, so next, because we've deleted the points of this mesh, we have some degenerate primitives. If you delete primitives, that's not a problem, but if you start deleting points like this, you should make sure you run a delete node or a clean node. The delete node is simplest in my opinion. All you have to do is go disable by number, go to degenerate, and enable delete degenerate primitives. That will get rid of any junk polygons that are still part of this mesh. And then finally, let's go ahead and add an ID to this stamp. All I've really done is grab the iteration of this loop and stuck it in here. So every building right now will have an ID. If we go ahead and view this guy, and let's bring our loop back. Now every mesh here is colored based on that ID. So we have a unique stamp for each building. And we're going to use that later, because ultimately each building needs to identify itself and its neighbors. So it doesn't start to look at itself for proximity to other objects, right? It should only look at all the others. So that's basically our footprint, and this should be sitting right below our buildings. Like I said, it uses the lowest pixel of the building. If you want to make this more advanced, you could probably find some tricks to grab the grid level of each structure, or alternatively load in the meshes from the content browser instead and instantiate them on the points of these objects. So let's go to the next step. We have this asset now, and let's have a quick look at what happens if we apply these stamps here directly to the output of our tool. I'm just going to grab this channel here and plug it directly into the output. Next, let's go ahead and save this. And if we go back, go to the HDA and find our mesh stamp asset, I'm going to re-import that. Of course, the only thing this is going to do now is actually import our footprints and generate those as meshes, but that's fine. I'm going to rebuild the asset. Alright, so at this point, everything we just had, our tool, has disappeared, but it's actually still there. Actually, where it is over here in the sky. And that's because the tool currently has an offset. You see, when the buildings got imported, they got imported in relation to world center, which is approximately here, right? But the tool itself, the asset itself, is located there. So it has an offset, a world offset, if you will. Now it is possible to go to the input of the asset and tell it to not keep world transform. And what that will do is it will basically make all of our buildings snap to center position of our tool. Of course, I don't want to do that. I need to make sure all of these structures are actually located in the relative position to each other. So we can't enable this. Instead, what we have to do is we have to know what the offset of the tool itself is and then undo that so our mesh ends up in the correct position in the world. And that's where the world transform node comes in. So let's go back to Houdini and let's make a small adjustment to the asset. Over here, we have this world transform node, and at the moment this node is already set to its default configuration. By default, these settings should work, except we do need to make sure this is set to counter rotation. I do know that. So what I'm going to do is I'm going to copy this node and I'm going to plug that into my output here. Now what that's going to do is going to make sure this guy now sits in relation to the center of the asset. If we actually look at this in world space, however, notice how it's sitting in the correct place of all the input data. So this lets us know we're actually looking at the right position. This is the right place in the world. If we look at this in show all objects mode, then you're looking at it in world space. If you're looking at it in hide other objects mode, then you're looking at it in object space. And the data that we're providing to this tool right now is being provided with a world offset. Each of these objects here has a world offset built into it, including the geometry container itself. That's basically the asset inside of Unreal, so this offset can be read in and corrected for. And that's what the world transform node does, among other things. It can also correct for the landscape itself as well. And if we make sure we save this, re-import, and let's rebuild. Then now our footprints will be below our structures as they should be, even if I go ahead and move my tool, right? If I move the tool over and I give it a rotation, at least a rotation in the z-axis. It doesn't work as well if you start rotating it in any of the other axes, so please don't do that. But you can have a rotation on the asset. If I then go ahead and recook it again, then it will basically snap everything back into position, because internally it's going to read these attributes from the assets container, this geometry container, and it's going to correct for it. So even if I go ahead now and give a rotation in, let's say the Y rotation, because that's ultimately how Houdini reads its up vector, it doesn't actually move, right? Nothing changes. And that's intentional, because this node undoes that particular transformation. So we got to make sure we put one of these nodes in on our output in this case. Now let me plug this back together the way it used to be. And I'm going to get rid of this asset. But basically the world transform can be used to either correct for the output or for the input. You might want to correct for the input, for example, if your inputs themselves need to correct for, say, the offset of the landscape. Like, for instance, if we are processing our landscape as centered on the center of the world, right? Which some of the tools in the toolkit actually do. Now, about that, let's have a quick look at some of our data that we're providing to the tool. If we go over here, we will find the load multi-caches node. This node is currently being used to pull in all kinds of data from our cache, including the world data, which describes these grids, the tile locations of our map. It's also being used to pull in the road information right now, the processed paths and the blueprint splines. Let me just expand this a bit so you can see everything. We can even load in other information, such as selection blueprint splines, which might be in the map over here. We can load in our path grid if we need to run a pathfinder for something, or we can import this as points as well. This is a little heavier depending on what we're loading. Points are lighter, but this is only the point positions of our grid. And we have the raw paths, which are, well, basically the paths of the roads before they are post-processed. And next to that, it's also able to load tiles as well. So at this moment, this tool is told to load the composite pre-procedural layers from the master folder. If we go over here to the blue output, we will see that the landscape of this section of the map is currently being loaded. And that is dependent on the input of this node. The load layers node, which is a different node, has the ability to load based on the coordinates or for the entire map. But this node here in particular only loads data that is required. So if we actually go over here, we see that this is the data that we're feeding it, which is the building footprints. And then the load multi-caches node here is only going to load that data which sits near that geometry. But we can expand that range by using expand range over here. So if we set this to say 2000 meters, then everything in a radius of 2000 meters from these objects is going to be loaded, which of course is way more than we need. So in this case, I wouldn't set it this high, but it is possible to do so if you need it. Incidentally though, loading more tiles does mean that it will take a bit more time, so take that into account. But okay, we don't need as much geometry, so let's go back and set this to 50. And that means it only loads the area directly surrounding our geometry. So let's turn this back off. Now, right now, if I were to look at this data, it is currently being loaded based on Unreal World Space. Center of the world is here, and this is the left landscape, landscape 2, and this is the right landscape, landscape 1. Right now I'm focusing on landscape 2 as the active project name. What I can do is tell it to center on this landscape. If I do that, it will actually push the landscape into its center position. And this can be useful in case, for example, we need to sample all of our data in the centered position of our world. For example, our caches are often saved in a centered orientation and then need to be offset respective to the landscape that they belong to. Let me go ahead and load one of those caches here manually. I'm going to grab a file node, and then over here I can type $ Massive Worlds Toolkit for the local variable for the Massive Worlds folder, and then let's look for the cache folder. If I navigate from there, all I have to do is select one of my landscapes, such as landscape 2, and let's go ahead and grab the processed paths. If we load this instead, notice how it basically has the same data right now as what the load multi-caches is loading, except of course it's loading a whole lot more. Now if I want to offset this back to its Unreal World Space, so let's remove centered on active project name, then everything is going to move. Now in order to make sure we know where it belongs, we can actually use the information that is stored in the world data file. The world data file is located here, also in the cache folder. Now in order to get the world data file, we can grab that using the landscape extraction node when we are extracting out our landscape from Unreal. So over here we have the extract Unreal landscape asset. We can scroll down here, and here we will find the ability to extract out the landscape's data to disk to a BGO file. I mentioned this earlier in the slides. And then below we have the ability to extract out the world data. Like I mentioned, the world data is a small file that basically stores information about where in the world this landscape is located, and to know where the tiles are of the landscape itself. But that's basically how we get the world data file. It's extracted when the landscape is. So if we go back to Houdini and we have a look at this world data file over here again, you'll notice how this one is actually in the correct position for our landscape. So this information over here can be sampled by the world transform node. So let's go ahead and grab that one. Plug that in. And then let's go ahead and turn on the offset. We want to move it along with the landscape offset in this case, away from the center. And then we're going to use landscape 2. Now if we compare this to our load multi-caches node here, we load that, you'll notice that as of yet it's not actually in the correct position. And that's because at this moment this cache is correcting for the world transform. So in this case we need to disable that. Let's go over here and disable world transform and also rotation. As a result now it's basically in world space without the offset of the asset. So you have to consider what offsets you need in Unreal and in Houdini. Outputs to Unreal would have to take into account the offset of the tool in world space in Unreal. So basically the asset that we're loading here has an offset to world space, and that needs to be corrected for. But if we're working in Houdini space, then you might want to work in a centered space, or in a space representing Unreal world space without the offset of the asset itself. Whichever correction you want to use, I found this node can do all of them. It's just a matter of trial and error and finding out which combination of offsets each type of input that you're feeding to the tool uses, and then how to correct for that using the World Transform node. Let's go ahead and continue with the load multi-caches node for a second. Now the reason that this node can load multiple caches simultaneously, and not for just one project, but for multiple projects, is because it has a file called the multi-project cache file. This is a very simple file. It doesn't contain much data, but basically what it stores is which landscapes belong to your current active project in Unreal. Let's say we zoom out here. Here you can see we have two landscapes, landscape 2 and landscape 1. Both these landscapes exist in the same scene, but they're two separate data sets in the Massive Worlds dataset over here. If we look at the load multi-caches node, it uses a file called multi-project. If we disable this, right now it's not loading anything, because at this moment we are not actually telling it what data to load. Instead, we can go down here and then manually specify which projects we actually want it to load. This setting up here, the active project name, does not actually tell it to load a project. It just tells it which one to focus on. If I tell it to center, it will focus on this landscape. Or I can tell it to filter out the active project entirely, or alternatively, isolate it. And this can be useful depending on what you're trying to do. But the problem, of course, is if you're trying to use this in a tool context and you want to make a tool that can work on multiple different Unreal projects and different landscape configurations, you don't want to go hard coding this into your tool. Instead, what we can do is we can actually go ahead and save out the multi-project cache file, and we just have to go ahead and specify which projects belong to our current projects, and then click Save All Multi-Project Presets from Settings. Assuming these parameters down here are set correctly, we can click this button, and then if we go to our cache folders, you'll notice that the multi-project file in all related caches will have been updated at our current timestamp. Now the only thing you need to do at that point is say load multi-project preset from active project name, and at that point, as long as this file is present, it will simply go ahead and load the data for all related projects. So you don't have to worry about what projects are specified down here. This can be completely ignored because as long as those files are present, it will simply know what to load. And every asset that has this node installed and has the correct project specified will know that too. So you only have to set it up once and then it should just work across the board. Now before we move on, I quickly want to focus on some of the more specialized loading nodes that don't focus on loading everything all at once. So let me quickly look at the load layers node and the recombine paths node as well, because they do have their own purpose. Let me quickly grab a load layers node. Let's press tab, go to the toolkit, Massive Worlds, and then down here you'll find the Massive Worlds load layers node. Let's open this one up. And for now, I'm just going to plug this in as well, because by default, this node is going to try and load using the same type of setup as the load multi-caches node. It's going to try to load it based on its input geometry. So over here, we'll leave it on curves and points. Now, of course, we need to tell it what project to load first. So let's go over here and tell it to load landscape 2. Then next, we need to tell it what layers to load. Now by default, it's going to apply these layers as height to the input geometry of the node. So over here, we can say sample layer. We're going to load the pre-procedural composite layer. As a result now, it is trying to offset this geometry to the landscape that it's loading. Let me visualize the landscape itself by visualizing this blue output over here. I'm going to press Ctrl Shift so it templates it as geometry. Now, you will notice that the stamps are not sitting on top of the terrain. And that's because this landscape by default is going to be provided in a centered context. If we want to make sure that it sits in the same world context, we can go to the Load Layers node, go to its output, and then correct for the landscape offset right here. So this node has a built-in world transform node, and we can control it right there. So we're going to transform again along landscape offset. And now you'll notice that our stamps are being projected to the terrain. Of course, that's not what we're trying to do in this project, but I just want to demonstrate that this is possible. We can pull attribute data from our maps using the Load Layers node itself. We can also load additional data. So if we want, we can also tell it to load a different layer. Like, let's say we load the darken layer. And instead of outputting this as height, let's output it as an attribute. I'm going to output this as color. So now we can actually see on our geometry's output the darken layer represented as a grayscale, right? That's pretty useful. It allows us to grab and sample information from our layers at location directly to input geometry. Of course, we can also use this to just output the landscape itself. So right now it is outputting the composite pre-procedural layer. It's outputting the composite pre-procedural layer as height, and it is outputting the darken layer. Now you might notice that it's also showing a mask. That mask is actually the slope that it's currently grabbing from the terrain. If you don't want to see this, just turn it off. It actually makes the loading process a little bit faster. Computing slope does take a little bit of memory. Now in some cases, you don't want to load around geometry, or you don't need to project information to geometry. In some cases, we just want to load our terrain data based on a certain coordinate. That's also possible. Let's go ahead and switch the tool over to Tile ID mode. In Tile ID mode, it will load all the tiles based on our current landscape, based on their ID. So in this case, I could say I want to load all tiles between x, 0, and 2, and maybe y, 0, and 4. This does take a little bit more time to load because it has to load more files, but it does allow you to grab specific quadrants of your terrain. If you want to load the whole terrain, just set this to 1000 by 1000. That should basically grab everything. Of course, this does take a bit more time. I'm going to set this back to, let's say, 2 by 2. And there's one other function I want to show. Over here, we have loading method. If we switch this over to by type instead of specified layers, then instead of loading specific layers, we actually have the ability to load subsets of layers. Let's say we want to load all the composite layers. This will mean that it's going to output every single composite layer, but it is going to output it as a fog type height field. This can be useful in some contexts where you need to grab all the information of a particular layer set. Alternatively, we could also try to load all our custom layers, if we have any. In this case, it is loading the exposure layer, as well as the mesh stamps layer as well, which is another custom layer. Anyway, that's the load layers node. And then next, we also have the Recombine paths node. Now for that, let me have a quick look down this network. Over here, we are currently extracting out the processed paths and the blueprint splines. If we go down this line here, we'll find a BLAST node that isolates out just these groups. If we unpack that and we go over here, we will find the path stamps asset. This is a simple asset that has the ability to create a stamp out of these road splines here. It basically grabs the attributes on the lines, including the width, and it creates a stamp out of it. This is a very simple asset, but it can be useful if you have some road splines that you need to give some width. Now you might notice that if we look at the transition point between two landscape caches that it doesn't properly transition. And that is because the load multi-caches node does not correct for two different caches that intersect. This is where the Recombine paths node comes in. Now, in order to get this to transition properly, we will have to use a couple of Recombine paths nodes instead. This is one thing that the load multi-caches node currently does not do. This might be added in the future as is necessary, but for now, let me grab a Recombine paths node. Let's press Tab, go to the toolkit, Massive Worlds, and let's find the Recombine paths node over here. I'm going to drop down one for starters. And for starters, we need to tell it what landscape to load, because this one only loads one landscape at a time, though it does have multi-project data output as well. Meaning that by default, and this is enabled by default, it will load the multi-project file over here. Then you will notice that it's currently loading both data sets, the active project and the inactive projects. Now, if we go over to configuration and we go to multi-project transition, you'll notice that it is currently loading this data. If we don't want it to do that, we can disable that. In this case, it's only going to load the cache file for the active project that we've set over here. The reason you might want to do this is because this allows the node to transition the roads between multiple landscapes. Let's go over to where our transition was. You'll notice that this is actually creating a smooth transition. I'm going to go and grab a copy of the Recombine paths node. And let's set this one over to landscape 1 as well. Let's let it load. And one thing you might notice is that currently it is focusing the landscapes again on center of world. Let's go to output. Again, correct for landscape offset. Let's do that on both. And let me grab a merge node over here. The yellow output is basically the same output as the path stamp, whereas the green output is the pure curves. So if I look at both of these and I look again at this transition point, then you should get a pretty smooth transition between these two. And this is because the node has the ability to correct, or rather blend, the processed paths between multi-projects. And this is the blending strength. If you want to know more about this, you can read the help file of this node. Like every other node in the toolkit, it comes with a full-on help card and a lot of useful information that you might want to know in order to use these tools properly. If we go to the output again and we go to color visualizer, we can set it to project edge transition distance. Let's turn that on both of these. And this allows you to see where that blending occurs. If we zoom out, you can see that all across the edge of our terrain, where our two landscapes meet, it will try to blend the roads. Now it does this for processed paths that are made from waypoints. Now you might notice that there is a road over here that doesn't do this. That's because this is a blueprint spline. And blueprint splines are assigned to either one of the two landscapes. Now in some cases you might need to load all the data inside your current landscape, even if that data is part of a different landscape's blueprint cache. If you want to do that, you can enable this option here, include multi-project blueprint splines inside the project area. Enable this, and at that point, this node will load whatever blueprint splines actually intersect with your current landscape, which is useful in this instance here. Let me just go over and disable my guides so we don't see all of this extra data. Notice how enabling this option makes this road appear. And that is because there are two blueprint splines in this area inside landscape 1 that belong to landscape 2, to the cache from landscape 2. Now, blueprint splines have the added benefit that they can connect up to the networks of neighboring landscapes, even if they aren't part of their own data set. As a result, they can transition between two landscapes and connect to the network on either side. The processed paths here only go up to the edge of the terrain, meaning that if we were to focus on, say, only one of the raw paths on one of these Recombine paths nodes, let me just bring up the grid for the left landscape here, and then focus on the left landscape's paths. You'll notice that it stops right there. And the same thing's true for the other landscape as well. They do connect to the same location, which allows them to transition using the blending function of the Recombine paths nodes. However, because the grid itself between the two landscapes only goes up to the edge of the landscape itself, it doesn't allow our ground-based connections to cross from one landscape into the other. So if we want to create a bridge or a tunnel, we would normally have to use a spline path. In fact, if we were to look at some of our tunnels or our bridges, and we look at our edge groups using the display group and attribute list here, we can see that we have a tunnel over here, as well as several bridges out in our world. But none of these are currently crossing the transition between our terrain. And that's because right now the splines that you can draw with the road editor don't properly connect to the other landscape when they cross between two landscapes. The blueprint splines, on the other hand, do this. So if you want to go and create a bridge or a tunnel that transitions between the landscapes in your terrain, like for example this bridge does here, then I do suggest that you use a blueprint spline instead. I might update the toolkit in the future to support this, but what you want to do for now is make your roads go up to a point near where the bridge or tunnel should start on one landscape. Do the same thing on the other side, and then simply draw a blueprint spline between the two that will form your bridge or your tunnel. It will connect on either side, and it will allow you to have a bridge or tunnel that crosses between the two landscapes, no problem. But alright, let's go back to Houdini, and let's have a look at how we can use this information to proceed. I know this was a little bit of a detour, but I wanted to make sure that you understood the different loading nodes that you can use to grab information, such as the landscape and the roads, so you can use that in your own tools. While I might take some of the features from one node and add them to another, like the road blending might be added to the load multi-caches node in the future, at the moment that is not supported yet. So in that case you'll want to use the Recombine paths node. Anyway, if we take the data that we're receiving from our load multi-caches node here, and we look at the paths, we unpack that, and then we can start using it to identify where our roads are around our villages, because this of course is loading in our blueprint spline data. Let's grab only the information that we actually need. I don't need the whole road network here, so what I'm going to do is grab my building footprints, and then I'm going to mark them off using a simple XYZ dist expression over here. I'm going to promote that to a couple of edge groups, and then we can use this polycut to only isolate the roads that we actually need within our stamp. Then I'm going to grab my path stamp here, turn that into a proper stamp with width. We can use that then to apply that to our terrain using the weighted height transfer node. Now let me explain how that node functions. Let's go up here, because over here I've set up a little example with our current landscape and a couple of Houdini icons. So if we look over here on the merge node, we can see that we have two, let's say, stamps with some geometry detail in them that are vying for control over the same piece of landscape. Right now they're close enough together so they should have some overlap. Let's go over to the weighted height transfer node down here. Now the weighted height transfer node can be used either in combination with the PNet node, the standard terrain workflow in the Worlds Toolkit, or it can be used as a standalone stamping node, depending how you configure it. Now let me bring back my slides for a minute, because I think it's a bit easier to explain with some graphics here. So the weighted height transfer node has the ability to take the stamp information that we feed it and transfer that to the terrain. Each voxel in the landscape can sample from multiple stamps at the same time, determined by the amount of samples that each voxel is allowed to make, and it will find a weighted average for that voxel to return a height value between them. So in this instance on the left, for example, we can see that each stamp has a different fall-off pattern. Depending on the height of the stamp compared to the terrain or its depth, it can also have different types of fall-off patterns. Next to that, there's also a weight influence from each individual stamp. In this case, they are overlapping each other, and as a result, they start blending when they get into each other's influence radius. And because it works with height fields, it can be used in your generic height field workflow, but it can also be used in the toolkit using the process and export nodes or PNet nodes. And in that context, it actually works in a very efficient way because it will only apply its terraforming to the tiles that need to be modified. Now, in order to make each stamp act with its own fall-off and weight values, we can provide these as attributes to the stamps themselves. We can do this using this type of setup, where each stamp has its own variables that are then fed to the weighted height transfer node. Over here is a little list of the different attributes that we can feed it. Normally these are point attributes, though some of them can also be provided as primitive attributes instead. Now the most important variables that we are going to be using here are the fall-off minimum, maximum, and reduction values. If we set a minimum and maximum range, then the fall-off reduction acts like a 0 to 1 range and pushes down the influence of the fall-off. So if we set it to 0, it will use the fall-off maximum. If it's set to 1, then it will use the fall-off minimum. In that sense, it acts like a linear interpolation between the minimum and maximum fall-off using an inverse multiplier. Let's go back to Houdini. Let's grab this stamp over here, which incidentally is the right one, and let's move it below the stamp on the left. Notice how the terraforming influence is way stronger on this stamp, even though both pieces of geometry are actually identical. This is because of the weight variable set inside each of the points on these stamps. The stamp at the bottom has way more strength and deforms the terrain far more because it has a weight value of 1, whereas the other stamp, the one on top, has a weight value of 0.1. Because of this, it effectively pulls the terrain down towards the bottom stamp than it would towards the top stamp. If we change this weight around, however, and we set it to a value of 1, then it will have a linear transition because both stamps have equal influence, and because they're overlapping each other, it effectively makes it into a ramp. Of course, if we set this to a value of 10, then the top stamp becomes way more influential. Now you will notice that there is some non-linear transition going on, and that is caused by the fall-off. The weighted height transfer has several fall-off controls that allow us to control how the fall-off will look like. In this instance, we are using a simple Bézier spline. If I change this fall-off pattern, however, notice how the look and feel of the transition of our stamps to the terrain changes. And this can also be applied to different orientations of our stamps as well. If the stamps were below the terrain, let's push this one down. And if we then set the fall-off type to complex fall-off, then you'll notice that we actually have different fall-off patterns depending on if the stamp is below the terrain or above the terrain. When this mode is enabled, The height of the stamp in relation to the terrain determines which fall-off type is going to be used. If it's level, it will use the standard one, but if it's below or above the terrain, it will use the fall-off up or fall-off down. And this will allow you to create different patterns depending on the height of your stamps to the surrounding terrain. That's pretty useful if you want to create different types of blending for cliffs or for upward rock walls, for example. You can even use complex blended fall-off. This will add even more different types of fall-offs to the mix, but I won't go too deep into this right now. Of course, feel free to read the help files because they will explain everything that you need to know about how these nodes work, as well as the example files that I've provided with the toolkit. Now, the way how the fall-off is controlled is through our fall-off attributes. If we switch this guy back to be a blend between 0 and 1, and let's pull this stamp a little bit further away, then you will notice how if we start changing our fall-off itself, it's going to shrink its influence. This is basically the transition from the stamp to the surrounding terrain. This controls the distance. Now, the minimum range is the lower bound of our fall-off's strength. If I lower this value, notice how it contracts. As a result, now we are probably dealing with a 1 meter fall-off. And we can control our fall-off using either the fall-off strength or by using our fall-off reduction values. Now, they basically do the same thing, but we can also use it with a noise. So let's have a look at this one. If we apply that to our terrain and we start to cycle our offset, notice how it creates a completely different pattern. It changes the way how the fall-off transitions from the mesh to the terrain. Now, in order to create a good transition between our geometry, we need to also account for the internal fall-off. And this is a feature that I've upgraded in the latest version of the toolkit. So if you've downloaded the latest build, you should have this option. Now, normally the fall-off only transitions from the stamps and the exterior terrain. And then any blending between the objects is a blurred blending. It makes samples between the different objects and then it determines the most optimal height of the terrain at each position. However, with this latest update, it also takes into account the fall-off internally between the stamps. And this is something we are going to use in our example here. I'll show you another example in a second, how this can be useful. So at this moment, these two stamps are blending together based on their weight values alone. If I move these stamps in close proximity to one another, and I actually start overlapping them, you'll notice how, because their weights are equal, the ramp that forms between them is also pretty linear. We already discussed that, that's because of the weight values. But we can also control the weights internally by using the fall-off to manipulate the weight values based on the distance to the stamp in combination with the distance of the fall-off that this stamp is using. Let's enable this option, and you'll notice that the fall-off changes its behavior. If I move these stamps a bit further apart, you'll see that they do maintain their composure a bit more. If I disable it, they'll start blending much more. And that's because they have a limited fall-off range, and that fall-off range determines that this stamp cannot override that stamp. Let's have a look at the road builder. If we look at the PDG example step 1 roads example file in the toolkit, you will find that we have the weighted height transfer roads right here, which takes the road hulls provided to the terraformer and stamps them into the terrain. If I use a pure terraforming without internal fall-off, but I include more samples to retain my resolution, then you'll notice that the road here starts blending because these two roads are in close proximity to one another and they're pulling influence from each other. In some cases, this is desirable, like on intersections where you want your roads to transition between the different elements that intersect. However, in this case, we have a side road that's moving down lower than the main road, and it's actually pulling down the road surface of this road. And that's not really a good thing. So if we take into account the fall off that this smaller road has, which is much lower, it has a much lower terraforming distance, and we also take into account the fall off reduction that's taking place within these splines, then we start to look at something much more controlled. In this case, the side road does terraform the terrain down, but its influence stops much sooner and therefore doesn't intersect this road, which maintains a nice smooth road surface, even though our intersections are still blending. And this is done by turning on the internal fall-off value and not subdividing our input geometry as much. As such, there are two ways to handle this. Either we add more subdivisions, which basically means that there are more points to sample in our source geometry, and therefore our sample strength runs out of samples nearby much quicker than if this was a lower subdivision count. Basically, the resolution of the mesh is increased, therefore you need more samples to get a blended result. Alternatively, we can also lower our sample strength, but doing so does mean that we get a less accurate result. So maintaining a decent sample strength or having more subdivisions allows you to control how the meshes blend. Now, having more subdivisions and having more samples does create a nicer transition. You basically have more resolution to play with, but it also means that the result itself takes longer to calculate. And if you have, say, a road network that needs to be computed, that's a lot of samples that it has to make across the entire map, because it's basically affecting everywhere that the road touches. So if you're going to do that, it might actually be a better idea to use a lower subdivision count and then use internal fall off to retain more control over the transitions between your roads, while still having a decent amount of resolution, meaning that even your smallest roads would still terraform in properly. Basically, it's a balance between having enough resolution and making it fast enough, and the internal fall off can help with that. Now, next to that, we also have the smoothing strength value. Now, the reason the smoothing strength is useful is because it actually removes some of the artifacts that you might get between two transitioning pieces of landscape. Like, you might get some awkward pieces of terrain because it uses samples, and depending on the amount of samples you make, this can result in a very rough terrain with lots of bumps, or even if you use a higher sample count, it still can create a little bit of artifacting. The smoothing strength adds a little bit of smoothing on top of that to remove those artifacts. But you want to be careful with this because it can blow out some of your detail, and it can create some undesired transitions if set too high. So like I mentioned, it's about balancing out these values so you have control over your results without losing your detail. Now, in order to create a good transition between our two pieces of geometry, we want to make sure that our fall-off always does what we want it to do. In this instance, for example, we might want our geometry to blend when they get in close proximity. This can be useful if you want to make two roads that are supposed to intersect with each other, create a good transition to one another. But in other instances, such as with our buildings, we don't actually want them to influence each other, because if they were to do that, then they would either pull the terrain down if there was a stamp below it, or it would push the terrain up into the building. What we actually want to do here is control our fall-off range per stamp so that they never have overlapping fall-off influences. We basically want to contract our fall-offs down so that they sit between our buildings and create a nice transition between them without influencing the height underneath the stamps, which should always be at the height of the stamp itself. We'll do the same thing for the roads as well, and then we'll do some blending. So let's go over to the scene and let's see how we can apply this. Alright, with that in mind, let's put that into practice. Let's go over here to the left where we have our footprint generator. And what I would like to do is basically compare for each of these footprints the distance to the neighboring footprints, so we can set up that fall off reduction value, as well as all the other fall off related values that we need in order to drive the weighted height transfers down here. So to do that, I'm going to run this through another for each loop. So let's go to that guy. And this is going to retrieve the fall off reduction as an attribute down here. And that's what this color here represents. Red is a fall off reduction of 1, and blue is a fall off reduction of 0. Now each one of these also has a fall off distance, which is set in this wrangle node over here. What this wrangle node is going to do is it's going to first set the fall off value to 1, meaning that we're simply going to give each one a full fall off distance value. The reason we're using 1 is because we're using the 0 to 1 method on the weighted height transfer nodes down here. They are being set to range mode 0 to 1 using the fall off minimum and fall off maximum as 0 and 1 respectively. That means we need to provide a fall off value, a fall off minimum, and a fall off maximum. So we're going to do that right there. Then next, I'm also going to provide a weight value. Now at the moment, I'm going to set this to a weight value of 1 all around, meaning that every point has equal influence on the landscape around it. Now you might want to use this in case you notice that, say, your smallest buildings, which have less points, are being overpowered by neighboring structures which have more points. Because ultimately, if they all have an equal value, more points is still technically stronger than less points. So you could boost the weight on these guys compared to the bigger buildings if you absolutely need to. In this case, I'm not going to do that. I'm just going to leave it at 1. Next, I'm also going to flatten my geometry. Now at the moment I have this enabled, so if I want to see it in a flattened state, let me just go over and click on these guys. Now this is currently in 2-dimensional space, because if we go measure the distance of each building to the others in 3-dimensional space, we're going to be dealing with some diagonals, and of course that's not going to help our measurement, right? We'd be getting larger numbers than we actually need to. So we're not going to do that. We're going to flatten it first, and then we're going to make sure that what we feed our XYZ dist expression is the flattened point position of the point that we're currently sampling from. Let me just grab this guy, visualize its target geometry, right? So what we're going to do is make this guy here sample its neighbors for their distance, and that's going to retrieve for us a neighbor value. Let's grab that. If I move my mouse over this building, you'll notice that it's retrieving certain distance values based on the distance to the nearest piece of geometry that's currently templated. If we want to get a better idea of this, let me just temporarily remove the roads. Now you can see that the nearest neighbor building for this guy is about 9 meters away. Now the problem is our fall off value is 25 meters away. So what we want to do is to prevent this building from having a fall off value that exceeds the distance to the nearest structure. And that's fairly simple to do. We just need to take a bit of math. If we know that this building is at its closest point 9 meters away, and our maximum fall off is 25 meters, then we just have to say 9 divided by 25, and that will give us our fall off reduction value. But in this case, the fall off reduction is actually an inverted value. So instead, I'm going to take the maximum fall off, subtract the current value, and then divide that by the maximum fall off. So that will be the value that we need in order for us to reduce the fall off from 25 to 9 meters. Okay. If we do that, then we basically get this. Now, if we look at these larger buildings, their points in the back are going to be far enough away that they won't be reduced. So these points are still going to have full influence. But okay, let's go ahead and re-plug in our paths. I don't want to leave that disconnected. And then let's scroll down to our weighted height transfer. Because let's have a look at how this actually affects our terraforming. If we click on this, and here you can see that it creates this mask. The red area is pure terraforming, and the fading is basically where the fall off exists. Notice how the buildings that are more red and have more fall off reduction, as a result, also have a much shorter fading distance. Now there is a fall off start value here for the external fall off. If we lower that, then the fall off starts much sooner next to the structure, whereas otherwise it would start further away. If we go ahead and plug in a mask by feature node, and let's set this guy to, let's say 0 to 45, then now you can see the effect that it has on the terraforming around the structures. If I change the fall off start distance and make this say 10 meters long, then now the fall off won't start until it is at least 10 meters away from the current structure, unless it has to blend with something else, right? Because here there's two different buildings vying for control. But by default, these values here control the external fall off, the fall off distance between the object and the terrain. Or in other words, its terraforming mask. Let's set this back to 2.5. Now our goal here, of course, is to create as clean a terraforming as possible. We want to make sure that our structures are properly transitioning to the surrounding terrain, while also not being intersected by the terrain or floating above it. So if we were to look at this here, maybe we want to make sure that this building isn't intersecting too much and this one isn't floating. We can do that, of course, by changing our subdivision count. A lower subdivision count is definitely going to cause more floating, at which point we'll have to change our fall off values for, say, the internal fall off, which will help straighten this out a bit. Maybe if we set it to 5, it's going to be a bit sharper. But if we don't have enough samples, then we can also go ahead and maybe just increase our resolution, and that's going to make this a little bit sharper. Go ahead and play with these values until you're satisfied with the look of your terraforming. And then next to that, you can also go down here and maybe mess with the patterns if you want to. I'm not going to mess with this much further. Let's move on, otherwise we'll lose too much time. Now, as you might recall, we are actually going to create a stamp that overrides the current terrain, and that includes the roads as well. So we need to make sure that we include the roads. Let's go up here and let's grab our path stamp again. I'm going to run this through the same node that we've set up here, this time not in a loop. And what I'd like it to do is, again, create a couple of fall off values, including a fall off reduction that we can get down here. Now at the moment you'll see that this isn't working because I've disabled this transform, and that's because, of course, this guy is sampling at height 0 and we have to flatten our source geometry. So this will give us the same type of fall off reduction values that we had from our buildings, and we can use that in this case as well. So if we go down here, here's our terraforming for the roads. Now the way how this guy is working is it's actually also using a mask. And this mask is constructed by taking the building footprints and then taking the road footprints and then subtracting the roads from our buildings. Plus I'm clamping it between 0 to 1 so we don't get any weird artifacts. This means that we now have these red areas which are the locations of our buildings where I don't want my roads to have any influence. I don't want the road terraforming to subtract from where we just stamped in our buildings, right? Because otherwise it's kind of a moot point. At the same time though, I do want to make sure that the roads are as smooth as possible. So if I grab this mask by feature node again and I drop it over here, notice how we have a nice transition where the roads are nicely smooth and they're not interfering with the buildings. If we didn't have this mask set up here, which is set up right there under mask influence, and if I were to disconnect this, then our roads would actually eat into the space of our structures. And then we'd have, again, buildings that are either floating or underneath the terrain, because now the roads are applying an effect on the surrounding areas where the buildings are. That's what this mask is about. It prevents those areas from being erased. Now, if you wonder how I've created this stamp, I'm basically using the setup material mask node from the toolkit, which is a very simple example asset that is able to take the footprint of any mesh and stamp it into a height field below it. Plus it has some blurring and potentially even some edge noise if you want to use that. In this case, I am not going to use the edge noise. I'm just going to leave it like this. We're doing the same thing for the roads. Subtract those from the buildings, and then we feed it to this height transfer. Now you might notice that there is still a simple height field project node right here, and that's simply to make sure that if there is a case where our buildings aren't properly level with the terrain, like let's say maybe some of our smaller structures here, like this one, isn't quite at the terrain level, we still have a simple height field project that's going to take the voxels of the terrain and move them straight up to that structure. It's just a failsafe to make sure that the footprints of our structures are always properly flattened, at least as much as we can with the resolution of the terrain. Okay, so next let's go ahead and take this. I'm going to clear this mask out, because now we basically have our height field ready. We can take this into the engine. Of course, this is way too big. We don't want to make this a stamp. We need to cut this down. So what I'm going to do here is take my height field and make it into a very simple low resolution mesh. Then let's show the mask as a color. And then I'm just going to remove everywhere the mask is 0. So this is going to create a simple shape for us that we can then grab the bounding box of. Now I am going to make sure that this guy sits exactly at the height of our height field, which should be at height 0, but just in case, I'm going to flatten it to the point position of this height field. The point position being the center point of this height field right there. Then what I want to do is use this to create a mask onto our height field. So over here I have a node, a volume wrangle, that's going to create a simple mask with a fall off. I'm going to use 25 meters, that should be fine. That's going to create this mask here. That's going to be the mask for our stamp. So let's go down here and let's look at this bound node. If we grab the mesh shape and we run it over a bound node here, that's going to create a bounding shape which leaves about 100 meters on both sides and adds some height to it. We run that through this node here, height field cutout by object, and it's going to cut our height field, creating a very small patch around our stamp. Think of it like creating a localized stamp that isn't going to use too much space. We could even lower this if we want to and make it even smaller, but I want to have a little bit of margin just in case. Then over here you'll notice that I'm also applying some materials to this stamp. There's actually another layer in here. If you want to view that, you can use a wrangle, height field wrangle node. Just going to plug that in quickly. And we're basically applying a material called material stamp. So let's say f at mask equals f at material stamp. And as you can see, these are the footprints of our buildings. So that actually comes again from our footprints. We take those, we use another setup material mask node to create a suitable mask for our buildings. And then I write it to a new height field layer called material stamp, which we can then copy onto our main terrain right here. So again, this is fairly straightforward height field workflow. Then next, just in case we have some kind of error, which can happen if you don't have an object to cut out, this node can error out. I have a switch here just to bypass and disable this entire stream in case there is nothing to stamp. And then finally, we're going to take this mask and save it out to a dedicated layer called alpha layer. We're going to use that as the alpha mask for our stamp when we apply it to our main terrain. So now that we have this data, let's go ahead and create a visual representation that we can actually see within the engine. That's what this mesh here is. Now what I would like to do with this is create this gradient here that shows us several pieces of information. I want to see where my roads are in pure red. I would like to see where my terraforming influence is in yellow. And I want to see the overall terraforming stamps alpha layer in white and black. And we can grab this information from, in this case, our stamp height field, which is the mask. That's going to be our white to black color, basically the base color of our shape. Then we have our footprint mask, which in this case includes the fall off. That one comes straight from the weighted height transfer for the buildings. And then next to that we have this node here for the roads, right? We're reusing that, so let's just plug it in down there. Now what this script here is going to do is it's going to create a mask which has values that are either pure red or 66% red, and then a fade out value between 33% and 0. And we can use that later on here if we convert it to a mesh and then use this gradient on it to represent our different values. But I don't just want to create this mask. I also want to make sure that I can control the shape of my stamp using our selection spline. As you might recall, we set this up previously and it has several different values in it, including a selection proximity, which we can use as a fade out distance. So over here, what I've done is if I were to disconnect this, is that either we are using the fall off of the mesh that we created previously using the alpha layer, or alternatively, if we plug in a curve, let's get that back in, we have our custom selection spline that is creating that custom mask shape, right? We've shown that previously. Now, depending on if it's provided or not, this script here is simply going to say, if there is a spline provided, go ahead and recreate the alpha layer using the inclusion mask, which is created by sampling the XYZ dist to the selection spline. And we're using a fading distance that is sampled from the spline itself as well. So this basically recreates the alpha layer that was set up here previously. And then this part of the code here handles the black to white gradient, right? So that's the light pink part of the mask. We want to make sure we update this if we are providing a selection spline. If we are not using a selection spline, then we simply use the original mask provided to this node to begin with, which is, of course, this mask. Based on where our buildings are, that should be correct for our purposes. Moving further down, we will take the mask layer and we're going to multiply that down. And then let's sample the footprint mask and the road mask using this code here, volume sample. and then we can multiply that down respectively. So this creates the different gradients in our mask. We're just layering these things together at this point. And then finally, we need to multiply our mask down in case our selection spline is being used and is shrunken. So if I quickly grab this, and let's say we scale this down, this would basically represent the shape of our selection spline. If for whatever reason you only want your stamp to cover part of your buildings, this is what this is about. Anyway, let's return this back to the way it was. Alright, so now that we have this, let's go ahead and turn this into our mesh. And also, let's export it out. Because at this point, we have our stamp ready. We have our visual representation ready, at least in data form. Next, let's go ahead and pull some information from the location of our grid. So over here, I have my world data, which, if you might recall, is being sampled from the load multicaches node. It's actually isolated out here on the left. And this is basically a grid that contains the coordinates of our terrain, as well as the project name, or rather the landscape name, for each section of the map. What I'd like to do is create a stamp whenever this is saved out that saves to that specific folder. You might recall that from earlier in the video. So this guy is going to grab the project name and the coordinate of the tile that our town is located on. If its center pivot is located on this tile, we are going to retrieve from that tile its coordinate string value. Which in this case is x3_y5. And we are going to retrieve its project name as well. So we can actually sample that again using a xyzdist expression, which also grabs the primitive number that was hit. And then we can use that to sample these values and write them into our stamp. So now our stamp knows which coordinate it is currently on. If we look under our point attributes here, we should be able to see it. Coordinate S and the project name. Next, let's go ahead and remove the alpha and active tile layer, basically any layers that we don't need. If we look under our info panel, we can of course see which layers are available. The only ones that I actually want to have here are the height, the mask, the material stamp, and the alpha layer. The main ones that are important here are the height, the material stamp, and the alpha layer. Without those, this won't work. And then at this point, we just have to output this data, which means we need to create a visual output for the user. And we also need to export it out to our cache as these files right here. So to do that, we're going to grab the attributes that we retrieved from the current tile. And we're going to push that into this wrangle, which is going to create, or rather allow us to update these values. If we want to set a custom project name, we can do that. I've actually added a toggle where we can say get the project name from the tile or get it straight from the active project that we're working on, right? In case you need to override that for some reason. Next to that, we have the stamp ID. That's going to set this value here. And then we can take a ROP geometry output node and set this up for export. So let me make this a bit bigger. Over here, we have the string. I'm using the Massive World Toolkit local variable, which is going to give us the path to the Massive Worlds folder right here. Then I'm going to say write that to the cache folder, set it to the current project name that we're retrieving from our primitive, which in this case is coming from our geometry itself. So we're just sampling that. Then we're going to say write this to a subfolder called mesh stamps. Right there. And then we're going to create a file called cache underscore mesh stamp underscore the coordinate string underscore stamp and then the ID. And we'll finish that off by saying .bgo.sc, which is a compressed version of the Houdini BGO format. It's a little bit lighter, it's not as heavy. I would use that in this case. Alright, so with that we just promote this to the interface and we have an export button that allows us to push this out into the hard drive, right? Click this button and this should have updated. There we go, so that's my current timestamp. Alright, so that's it for the export. Now as for the visual output, I'll just quickly run through this. We have our stamp over here, our mesh. Let's go ahead and isolate out everything that's not part of the mask. Clean that up. And then this guy is just to enable or disable the visual, because once we combine this together, I want to be able to disable this from the interface, right? Then I allow it to raise it a little bit so it can sit above the terrain. We update the normals, clean out all the attributes except the normal and the color. Get rid of groups. And then finally, here's the main parts of my output. Normally I add an Unreal output name to the mesh that I'm generating. So in this case, it's called stamp visual. Then I pack it, which is going to turn this into a component for Houdini to output its own unique component. And then here I set a variable called hidden in game. This is the U property that Houdini is using in order to make these meshes here turn invisible whenever I press G. What this is basically doing is it's taking the component inside of my asset when it's created, and it's finding the hidden in game variable, and it's going to turn it on. And of course that's pretty useful because if you are going to play the game, you don't want your tools to show up, right? In general, I wouldn't want to include Houdini tools into any baked builds of this project anyway, but just in case you're playing in the editor, I don't want to have all these meshes flying about whenever I'm walking around in the scene, right? So there's that. Now, if you want to know how to get to these U properties, in general, you can right-click on a parameter and then copy its internal name. That can help. Basically, in this case, it's called linear dampening. And this gets us back to where our world transform node was located previously, right? So this one offsets it to be in the right position relative to the actor in Unreal's world space. So we get the mesh in the right place. Now, this node here is about the output of some of our information. So if we go to the interface of the node, you might have noticed that there is a string path here next to the save button. And this is simply to give the user feedback about what the name is going to be of our stamp. Now, this works fine if you want to make it work in Houdini on its own by just using a label and then referencing some attributes internally, just like how I'm doing here. However, in Unreal, I've noticed that that doesn't work well. So if I jump back into Unreal, then here you can see that I actually have this field in my interface. And if I update it here, it also updates the string. Now this is just a string field, but because this field updates every time the node does, it should always represent what it is that it's going to save it out to. So in this case, that's going to be this folder, this coordinate, and this ID. It gives you a bit of an overview and makes sure that you don't accidentally save out the wrong asset. Now, you might have noticed that the interface looks slightly different. That's because this video has taken me so long to record and re-record that I've since updated to Houdini 20 in this project. I've been testing with Houdini 20 recently, and so far the toolkit works just fine with it. Couple of warnings in Houdini, but nothing that breaks the system. So go ahead and use it with Houdini 20. That said, the interface does look a little bit different. Nothing major. It's just that now it actually allows you to stack parameters next to each other instead of everything just being in one giant list. Thankfully, that's been added. And then finally, for this node, I still have a preset node integrated. This node is able to either read or write the interface of our tool to an external file. That would be this file. And we're currently writing it to the default preset. So if we look over here under the preset tab, you can find that we're currently able to load a preset or save a preset. So let's say I say save preset, and I need to arm the exporter. And what this does, it also pops up this console here, which is telling me that it's currently saving these parameters. If I click save preset, it's going to write that to a file on the hard drive. So that would be this file here. And then you can also go ahead and load it. So let me just grab some of these settings, change them over. All right. And then I'm going to say load preset from file. And we have to make sure we enable the importer. At the moment, this node works via inline function, which does mean that it messes a little bit with the memory of the node. You might have to reset the node. But if you enable this, then it will reload my settings and restore them. And then it sets it back to save mode, so it doesn't keep reloading it. That's pretty useful. Now this node overall can also be used inside the PDG. You do need to use it in a specific way. You can check out the simple spawner example for that in the main example file. But for now, this will allow us to save our settings and to bring them back. And this works for multiple settings, including multi-parms, so that can be quite useful. Okay, so that pretty much covers the entire mesh stamps node. Let's look in the next chapter about how we can integrate this with the rest of the pipeline.